Harini, you are logged in. Are you there? Yeah, Josna. What from the figure? What do you visualize? A circular linked list should be having what typical feature? We have seen single linked list. We have seen double linked list. Let Josna answer. Sriyasa. Uh, we have seen double linked list, which was different than single linked list, right? So what? Saitya, wait. Let Josna answer. Josna, take a guess. I mean, let only Josna answer. Take a guess. Yeah, Josna, you're trying. From the figure, sir, can you? No, from the figure, I'm sure all of you have played this type of a game during your childhood and circular linked list. So, what is so special about circular linked list, or what is so different in circular linked list? Jolly weight in comparison to the single linked list and the double linked list which we have studied so far. Any guess? Okay, answer doesn't seem to be coming from her. Akshat Hirani, are you there? Akshat Hirani, are you there? Last node is not null, sir. Okay, okay, you are close to it, though not on it. Lanki doesn't have the last node pointing to null. Okay, Shravani, yeah, good to see some new names also coming up, and I'm happy whether Vishnu is saying first and last node are connected. Okay, very good. Then Mihir is saying last node again point to the first node. Okay, good. Last node will be linked to first node. Okay, Suprit, last node is linked to the first node. Suppose it's a, yeah, if we create a single linked list using a single linked list, when you are saying last node is connected to the first node, means what? Suprit, last node will be linked to the first node, so it will become circular. Can you slightly elaborate on this, Suprit? I like your answer. So in terms of linked list elements, can you slightly elaborate what you are saying? MB Suprit God. So you are saying the link pointer hold of the last hold the base address of the first. Yeah, yeah, got the point. You got the point. Good. So you are generally following. I'm happy, and other students are coming into the play. There will be no empty node. Okay, what do you mean by empty node? Anyway, so the circular linked list is a special type of linked list. Point one. Circular linked list is a special type of linked list. So it has got some specialty from something which we have so far understood, right? It supports traversing from the end of the list to the beginning by making the last node point back to the head of the list, right? As Suprit was on it, dot on it, that the last node, right? Uh, the structure is same as the linked list. So that structure has got int data and struct node pointer next. So the last node struct pointer next is having the base address of the first node. Somebody was saying, yeah, I think Josna was saying last node point to first node. So I think what Josna was trying to say is that the last nodes next pointer is having the base address of the first node, right? So that is the specialty. So as you see it on the figure, as you see it on the figure, say this is the first node, right? Indicated by the pointer first, and 20, 40, 55, 70. So 20, 40, 55, 70 are in single linked list mode. But the generally, so we have seen that the last node, and which is the last node? 70. 70 is next. We have equated to 0, and that's how we were able to stop by identifying the if the next is null, then that's the last node. If the next is null, then that's the last node. And we always were keeping a tag of the first node. So far we were we were not concerned because we were very clear that if any node whose next is null is the last node in the chain, right? That's the assumption. So in the while loop also we said cur of next not equal to null, cur is equal to cur of next, right? And we kept on advancing while searching, while displaying, and other activities, isn't it? But here that is not going to happen. So this is a small kind of a care you must take in managing the circular link list, right? So that is that. So this is the first and this is the last. Now, circular linked lists are usually in the sorted form. Circular linked lists are usually in the sorted form. That's not a compulsion, but the application wise, generally circular linked lists are in the sorted form. One of the application what I can think of, and all of you have tried it also, circular linked lists are useful in playing the video and the sound files in loop mode, isn't it? You create a playlist, isn't it? In all the say audio applications which you have on your laptops. You have your own favorite playlist, and you generally keep that playlist in a circular mode. In the sense, when the last song is played, it restarts from the first song. So there's a kind. This is one of the application of this circular linked list, that after the last song is played or after the last video is played, it rolls back automatically to the first song or the video. They are also a stepping stone to the implementing graphs, right? When we go to graphs, we'll see that a fair amount of idea of circular linked list will help us in the graphs, okay, which we'll be studying at an advanced stage. So now let us the same common operations: insert, delete, and search, right? So insert. Now there are two things. Suppose we are inserting an empty list, means we are starting the very first one, right? So we create something like a cur, a pointer, a current pointer, a temporary pointer, and struct node typecasted, and the size of struct node, right? This is a popular thing. We have been using this empty number of times as of now. So this is my cur. Assume that the base address is 1000. Assume that the base address is 1000. And then we have populated this data value with 10. We have populated the data value with 10. And then one more pointer we are parallelly working with. One more pointer we are parallelly working with. So my question to Sahitya, Sahitya, that is A1205. Sahitya, are you there from ITA? Right? This is a, yeah, good Sahitya. So this is 1000. The base address is 1000. The first is another pointer which is 1000. And what's this? Sahitya, are you getting my question? The base address of this node, the isolated node, that's the very first node. The base address of the very first node is 1000, but in the next we have kept it as Shaji, just wait. Zafruddin, just wait. Let Sahitya try. Are you getting my question, Sahitya? Why I am putting this 1000 in next? What do you visualize, Sahitya? See, this is the data. This is the structure of my linked list. This is the structure of my linked list, right? Right. So the base address of this node is say 1000, which is stored in cur also, which is stored in first also. And this is the next pointer, right? So this next pointer is also 1000. Why? Did you get my question, Sahitya? They are linked. So even if it is an isolated node, it's a first node, no, Sahitya. Now the first node also should be in circular linked list. Should the first node, very first node also should be in circular linked list? Sahitya? A Sahitya from ITA. Should the now I'm adding the very first node. Should that also start with a circular linked list? They can. You are not sure. Okay. Anyway, right. But you're very close to it. So even if it is the first node, even if it is the only node, that only node also should be in a circular linked list manner. That only node also should be in a circular linked list manner. Okay. So that is what we are ensuring. That's what you are ensuring. So when you create a node, when you create the very first node, the first node has got a special feature that the first node has got a special feature that the first of next is equal to first itself. What is the first of next? First, this is the first of next is this pointer. That first of next is equal to first itself, right? It looks a little funny. What is first of next is equal to first, right? What is in first? 1000. What is in first of next is a pointer. That pointer can store the address, right? What address we want to store? The 1000 itself, the base address of the same node itself. The same base address of the same node itself, right? So if you call this as first or call it at last or rear, whatever you want to say, call it as first or call it as last, both are having basically the base address there only. But if I call it as last or rear of next, that rear of next is going to be the first itself. Okay, and that's how we are linking the isolated nodes next to itself. Isolated nodes next to itself. Now, the care which you should take during display, right? The care one should take during display is what? Can I know the answer from Dhavalika Reddy CSE? Dhavalika, my question, I'll repeat the question. What care now I would like to display? Now this is in a circular linked list manner. What so far logic we were playing? That cur of next not equal to null. Cur of next not equal to null. Printf percentile d cur of data or cur of n. Right? But we do not have something like that. So what care we should take, Dhavalika? E section. Are you getting my point, Dhavalika? I hope you are in the class, you are attentive and listening. Okay, good. You are there in the class itself is encouraging. Yeah, and what cares you should take? Should I put it what while condition you will put so that it does not go into an endless loop? It should not go into an endless loop. Firstly, there is no condition where next not equal to null. That condition itself is not there. Every next, even if it is the only isolated node, that next has to be having the base address of the first node. So you never meet in a condition where the cur of next is not equal to null. means cutoff next equal to null doesn't happen. So the loop doesn't terminate. Okay, fine. If not Davlika, a number of you are trying. Uh, Go ahead, any one of you, as well as Davlika, any one of you. If you are done with an answer, just display the answer in the chat window. The care you should take is either in the display or in the search, cutoff next equal to first, right? If cur of next is single assignment operator, here, is it single assignment operator? Be careful. So also Davlika, you are assigning, are you assigning the value in the if condition? If you start assigning the value in the condition, it will go into always true. So you should be saying what? Some temp pointer, temp is equal to cur, when temp of next equal to first or what? Equal to first. Still I'm not getting any answer. Multiple guys are trying it out, but not a single answer. So that is the care which you should be taking. Right. Now insert at the end. We have seen insert at the beginning. The state was little easier. Now we must try insert at the end. Now there are insert at the end. So already one linked list is there comprising of 10, 20, 30 and 10, 20, 40 and 55. So this is my linked list, right? Now I am inserting a node. This is my earlier linked list. This is my earlier linked list indicated by the starting from 10 and last node is 55 circularly connected to the first. Okay. Now new of next is equal to cur. New of next is equal to cur. Why? Because cur is here, right? When I create a node, when I create a node, its next has to be not null, right? This is the last node. So presently, this is my new of next. I have first initialized it to the cur. Cur is standing here, right? Now the last node, call it as previous or call it as rear. Previous of next is equal to new, so that you connect it over here. You connect it here or here, and then take the rear over here, and then take the rear over here. So that rear is always pointing to the last node, right? So two logics. If you are keeping some pointer as rear or the last, which is standing at the last node, is standing at the last node. So as some of you are saying, cur of next equal to first, or cur of next equal to rear, right? Cur of next equal to rear, then you break or something, some condition you should be applying, right? So this is what should happen. Now let's see the code. Let's see the code part of it. Just go through it. Just go through it. Okay. So now we have a structure, int data and struct node link, right? Struct node link. And then as usual, we have a menu, which if you select the case one, it's going to create a very first isolated node. Again, that first isolated node has to be in a circular linked list manner. Case two is insert. Case two is insert. Case three is delete, and then case 4 is we are exiting, right? So correspondingly, I have some pointers in the global area, cur, first, last, and cur first, last, and temp. Instead of dear, I have taken it as the last. The first is always pointing at the first, and cur is a temporary kind of a pointer which you can play along with. And so also temp is another pointer which we need for some jobs. Oh, you want me to be louder? Okay, fine. I'm not audible. Okay, Sahitya. Can you hear me, Sahitya, now? Okay, fine. So there are the prototypes are create, insert, delete, and display. Now, having done that, what does the create function do? Now, just go through the code and try to visualize what the create function should be doing. So diagrammatically, you came to know the algorithm, but that algorithm which you have seen diagrammatically very easy to say, but the code converting that particular diagram into a code or that algorithm into a code is what is required. So we are giving a prompt to the user that enter the first element, then we have created the curve, right? So an isolated node, which is say we call it as curve, and that curve we are storing in pointer, that curve. So may take it the base address as 1000, and the name of the pointer is curve. Then we are populating this data. We are populating data with some value. That's what your ampersand curve of data. Then curve of link. What is this curve? Curve of link is this, right? You have seen the structure in the previous slide. So this is nothing but the pointer is the name of the pointer is link. So initialize to null. First is equal to curve, right? So another pointer first, which you have seen it globally declared, that first is also pointing at the same location. So therefore, my first also will store 1000 and cur also will store 1000. Now this last, right? This last is also another pointer which is always pointing. So call it first and call it last, being only node. So both ways I'm right. Both are pointing, both is having the same base address. And this last of next or last of link, I wrongly put it as next, but last of link or the cur of link is equal to first, right? So that is how we assign the 1000 base address and connect it back to our base, right? So this is one isolated node. Even if it is an isolated node and the first node, we have created this isolated and the first node in a circular linked list manner. Now let us see this code of insert. Let's see this code of insert. What type of insert I am doing? Having gone through the code which is visible to you, what type of insert am I doing? Am I inserting in the beginning? I'm inserting at the end, at end. Okay, good, fine. So, fine. So, we are taking, when you select the option as case 2, when you select the option as case 2, then we are prompting the user, then we are creating one more pointer. Now that pointer is your curve, right? So this already one linked list is there. Already one linked list is existing, right? And we are given a prompt to the user. We are given a prompt to the user, and that curve which he has created is an isolated one. So presently it is not in the linked list. The present circular linked list is 10, 20, 40, 55, and the 55 being the last node, and last of next is first. So this is rolling back to first. Now again here my mistake, I have said 1000. So let me correct my mistake. Let me give something else because it can't be 1000. So let's give it as 6000. Okay, save it. So I have created one cur, and the base address is say 6000, which is the base address over here. Next, cur of link is equal to null. Okay. Then we are saying last of link. Where is the last here? Presently, last of link is what? Last of link is 1000, right? Last of link is 1000. That last of link is equal to cur, right? When I say presently last of link is rolling back to 1000, but that first I have to break it and bring it over here, right? So last of link is equal to cur. So this is going to, what was storing 1000 is going to get converted to 6000, right? Now, cur of link is equal to first. Where is cur? Here. Where is cur of link? Here. Now, this cur of link has to be brought it into first, and you have to roll it back in this fashion. So that now the new linked list which will look again in a circular fashion, the new linked list which again in the circular fashion should look like this. So last of link is equal to cur. Last was here. Last of link was cur. It has been made cur. Last is equal to cur. Therefore, this last pointer, as which was standing over here earlier, has started coming over here, right? And then we made cur of link is equal to first, and rolled it back. Cur of link is equal to first, and rolled it back to the first pointer. Uh, are you clear about this? So that we are again in the circular linked list manner. Any questions, any doubts which you have in your mind? I think one step we can omit over here, and that is cur of link equal to null. No need of saying that, because anyhow this cur of link, instead of making it null, we are rolling it back to. So this is one step which we can omit. But other than that, anywhere you are not understood. Okay. Okay. So let's go further. Uh, can we say last of link is equal to first? Yeah, you can say that. Yeah, because last and cur are standing there itself. So Yogeshwar, yes. Uh, Yogeshwar, yes. Last of link is equal to first. Um, last is equal to and last of link is equal to first. Yes, you can say. Yeah. So now the next thing, and that is about the deletion of the node. That's about the deletion of the node. Now in the deletion of the node, in the deletion of node, uh, when it's the only node and that you can take care of yourself. If it is not a node and if it's the only node that you can take care of yourself. So I'll basically focus on this particular part, that's the else part. So in the else part, that cur is equal to first. So I have pointer which is pointing to very first node. Now I'm started using this temp is equal to cur. So therefore temp, first and cur, the three pointers are having the same base address. All these three pointers are having the same base address. Cur is equal to first, right? First is first itself, and temp also is equal to cur. So temp, first and cur all are pointing at the base address. Not what we are doing, we are trying to target this particular node to be deleted, right? When you say delete, delete at the beginning, right? So then we say cur of link is equal to null. Where is cur? Here. Which is the link? This. So we are firstly disconnecting this node with the rest of the link. Firstly, disconnecting this node with the rest of the link. So, and then we bring the first over here, right? That is this has happened. Cur of link is equal to null. We have broken this particular link. Cur of link is equal to null, and we said that I deleted the node. Presently, I'm not freeing. If I free it, then I won't know cur of data, right? If I free, I won't know cur of data. So simply what I did, I cur of link is equal to null. So I have broken the link. So I said deleted element is 10, right? Now I can free cur. So this cur has got freed. the cur has got freed. Then cur is equal to first, so the cur has come over here. The cur is equal to first, cur has come over here. Now there is a condition, first not equal to null, right? First presently is having a base address, so first is not equal to null. In case if it's an isolated node, then that node goes first, and then the first becomes null, right? Therefore we are taking care of that. Then we enter the condition while cur of link not equal to 10. While cur of link not equal to 10. Now what is left now? Previously, this 70, the node having the 70 value was connected to the first, right? So now that the first node has gone, this particular address has to be modified. This particular address has to be modified. So I'm entering into the while condition. In the while condition, as you said, cur of link not equal to temp. What is temp? Here. The temp was previously, if I take you little back, see temp was having the base address, right? This temp is storing the base address. I have freed cur, and that is the reason why I have one more pointer, because if I free cur, the address which was here, is will go. Therefore, that temp, okay. So yeah, cur of link not equal to temp. So we are advancing the cur till cur is equal to cur of link. And it advances. When will this condition fail? Because what is in temp? Previously, once again students, if the base address of the first node was 1000, that 1000 value are stored in temp, right? So cur of link not equal to 1000. So cur of link not equal to 1000, it has advanced here. Cur of link not equal to 1000, advance here. Cur of link not equal to 1000, advance here. Now it's waiting here. Now cur of link not equal to 1000, false. 1000 not equal to 1000, false. So it comes out of this while loop, and cur of link is equal to first, right? So therefore, after coming over here, the cur of link has come to the new first, and by that, because of that, we have reset the circular fashion of our linked list. We are reset the circular fashion of our linked list. Okay, so this is what we should be planning. Okay, so whether you insert a node or whether you delete a node, you always ensure that the complete linked list is in the circular fashion. So let me try and give a demonstration. I think I have the code. So this is the code what I was talking about. And display, of course, I don't want to spend time on this, because what is it? It's just displaying the in the while condition. I'm displaying each, but the care which I am taking is over here. Do you want to continue? I'm saying, okay. So the care which we are taking is that if I execute, let me first compile and then run it. So we get a menu. So I go for one, I display, right? So it's asking me to enter the value, say I10. So it has already called the display function. So the display has got one, and it has waited. It is not an endless loop. Yeah. So again, the menu is displayed. And now I would like to insert two. It's asking me the element. I say 20. So again, I'm calling the display function 1020. Had it be in a circular endless loop, it would have kept on printing 1020. And when you guys, if at all this comes as a lab in your final exam, when you are coding, this could be one of the kind of a difficult area. Sir, I have got everything, but unfortunately during display it is going in an endless loop. So be careful about that. Now again I say 2 again and say 40, and I get this. Now I would like to delete. So delete. Sorry, I'd like to delete So say 3, and it is going to always delete the first node. Again 3, again 3 is going to. So this way it is going on. It will keep on completing all the jobs, right? So what we have so far finished, what we have so far finished is hmm, we are done with the single linked list. Yeah. So let me turn this into green because we have finished it. Then we have finished with the doubly linked list. So let me also turn it into green. Then write a program that uses a function. Write the program that uses functions to perform the following operations in circular linked list. Right? Create, insert, delete, and traverse. So that also will convert that into green. Write a program that implements stack using arrays as well as pointers. That is your linked list. So this also we have completed. Then write a program that implements queues, again using an array and pointer. So, okay. So these are the 5 labs. These are the 5 labs. Let me save it also so that next time I do something else, I can get it back. Okay. So yesterday when I was doing the sorting operation, one of the students says, "Sir, selection sort. Are you using selection sort?" But there are other sorting techniques. So when we come to lab 6, we'll also know, of course, you must have done this in the first semester, but nevertheless, because it's a part of the syllabus, bubble sort, selection sort, and insertion sort. So then we can replace that selection sort with other sorts also, right? Then linear program that use both recursive and non-recursive function to perform the linear search and binary search. Okay, write a program to implement the tree traversal method, and write a program to implement the graph traversal method. So these are the 9 labs which are there in your syllabus, which are there in the syllabus. So out of which we are well ahead. We are already finished more than half. We are already finished more than half. So I think we are absolutely comfortable. Now, since yesterday, I already told you that no exam because something else is scheduled between first and seventh. But we are going ahead. We are going ahead as far as DS class is concerned. On seventh, so approximately 12 to 13 days you are going to get, and these 17 questions, including circular linked list, means what? Single linked list, doubly linked list, circular linked list, then skip list, then then our hash tables, right? In that, your linked list operation. Okay, all these things are going to be there. So all in all, we'll break that into 17 questions. For example, suppose you get a question on single linked list. So single linked list insertion, delete, and display is there by default, right? The question may be, in addition to insertion and display, also show that insert anywhere, insert in the beginning and insert at the end, right? So in addition to insert and display, delete a node from anywhere in the linked list, right? So such 5 variations of single linked list, 5 variations of doubly linked list, circular linked list, and your your what is called as hash table and open chaining. Any questions, students? And of course, those 200 MCQs, those 200 MCQs, and in these 200 MCQs, any 30 will come. No choice, all the students have to attempt. So 7th happens to be Wednesday, and Thursday all your individual faculties will review your performance. Individual faculties are going to review your performance. So before stepping into unit 3, before stepping into unit 3, I think I have built your ground for learning the binary search tree. Because binary search tree, you require a good awareness of doubly linked list. So that firm ground we have already created. So on Monday I will start unit 3. You have a quiz. We may finish a little earlier, but doesn't matter. Doesn't matter. So I'll request Shankar sir to take over and start your quiz today. The quiz is going to be on circular linked list. Okay, Rohan. Yes. Okay. Let's. Thank you for reminding me. So before I begin unit 3, I will uh, I will spend some time. Maybe one day we'll spend on bigger notation. Rohan, is it okay? Right. Yes, Mihir, anything? All right. So please take the quiz, all of you, and Monday we'll meet with bigger notation. Do we have DS unit test between 1 and 7? Unit test. This is a class test, Mayor, what I'm saying, because you are take it as a kind of a revision. Know how you guys are understanding, because your understanding has to improve. See you on Monday with a bigger notation followed by unit 3. Thank you.
Yeah, good afternoon, one and all. Is it my audio is clear? Yeah, which question? Rohan, which question, Rohan? Linked list one. Okay. Yeah, we will check it, right? But the answer was a node list. Okay, I will check it. Okay, okay. Anyhow, we will discuss, right? Discuss in the question, right? Meanwhile, we will check it that what is the correct answer and what is the wrong answer. Yeah. First one is linked list, right? We will check it. Okay, no problem. We will modify that one, correct one. Okay. Before the class begins, that not yesterday, sir. Which one? Which quiz? Which quiz, Rohan? Day before yesterday. Okay. Day before. Day before yesterday, right? Means today is the 25 means 23rd quiz. Yeah, I will check it. Yeah, I will check it, Rohan, the 23rd question, which is not a node list, this is a linked list, right? Yeah, I think this is question number 1. I will check it. Okay, not a problem. Before the class, we have the 20 MCQs and 20 minutes of time. It's a combination of circle linked list questions and little much of double linked list. Okay, please go to it. Just I want to start a quiz. Yeah, guys, just now quiz is started. Please go through the quiz. Okay. Right now I started quiz is 150, right? At the 210, I'm going to stop the quiz. Okay, 20 minutes of time, 20 quick questions. It does not have any programming metric. It is a just of a definition part of questions. Okay, it's a theory type of questions. Please go through it. And exactly 210, we are going to stop the quiz. Please go to the quiz.